Now that we've talked a little bit about rational equations, let's look at some more complicated examples. Like I said at the end of the last video, overall this process isn't really too bad. The first step is the worst one, figuring out exactly what you need to multiply by. But once we've figured that out, all we have to do is solve a linear equation. So it's really just this first step that we need to concentrate on. Exactly what do we multiply by? And we can see that this example might be a little bit more complicated. So our first step is to realize that that term in the middle does not look nice. So let's try to factor, and really that's going to be our first step. If you can factor a denominator, absolutely factor it. In this example, we need two numbers that multiply to be 10 and add to be negative 7. And we can see that negative 5 and negative 2 do that. Oops. R, not X. So now I've factored that middle term. And essentially what we're going to multiply by is whatever's on a denominator. We see we have an r minus 2 on a denominator. And we also have an r minus 5. So I'm going to multiply by both of those things. In my first term, the r minus 2's cancel, but the r minus 5 doesn't, so I'm just left with this r minus 5. My second term, I have an r minus 2 and an r minus 5 cancel, so I'm just left with 1. And in my last term, the r minus 2's cancel again, but the r minus 5 doesn't. So essentially, whatever's on the denominator is going to go away, and whatever's left, whatever the other thing I'm multiplying by, is going to stay. This is now r minus 5 plus 1 equal to, we need to distribute that, so 6r minus 30. Negative 5 plus 1 is negative 4. And now we have this very basic linear equation. So we need the r's on one side, so let's subtract 1r from both sides. That gives me a 5r on the right. I can add 30 to both sides. Negative 4 plus 30 is going to be 26. So now r is just 26 over 5. Like I said before, especially with these rational equations, it's very important to check your answer and make sure you don't get 0 in the denominator. And you can go back to our original problem, but a 26 over 5 will not give us a 0 in the denominator, so this is a fair answer. Let's try one more of these more complicated ones. Here, the denominators are already factored for us, so that's nice. And so we're just going to start multiplying by things on the denominator. We can see the first fraction has an n squared and an n plus 5. The second fraction has n plus 5 on the denominator, but we've already written that down. And the third fraction has n squared, but we've already written that down, so we have everything. When we start multiplying our first fraction, both of those things are going to cancel, both the n squared and the n plus 5, so we're just left with the numerator, the 5. My second fraction, the n plus 5's cancel, but the n squared doesn't, so I'm left with 4n squared. And then the third fraction, the n squared's canceled, but the n plus 5 doesn't, so I'm left with n plus 5. And now we can see that we no longer have a linear equation, we have a quadratic equation. Well, we solved quadratic equations by getting everything on one side. So when I subtract 5 from both sides, it's actually going to cancel. I have a 5 minus 5 would give me just 0. Well, we can factor. We see on the right-hand side they have an n in common. I'm now left with 4n plus 1. So, if I use my factoring principle, I have n equal to 0, or 4n plus 1 equal to 0. We can subtract 1 and divide by 4 to get negative 1 over 4. But like I said, it's very, very important to check these answers. We can see that if we stick the n equal to 0 back into the original equation, this last fraction, 1 over n squared, is going to turn into 1 over 0. So that's bad. So we actually only have one answer here. So this is why it's very important to check your answers, because these rational equations give us what's called extraneous solutions from time to time, meaning things that look like solutions but actually aren't. So make sure you do double check your answers on these.